Okay, welcome everyone to Cloud Data Driven Online User Group. Our topic for today is your performance tuning checklist. Who am I? I am Jean-Joseph, currently working as a data engineer. I've been in IT for over 18 years. I'm located in New Jersey, originally from Haiti, and I'm your host for today. The rules are you guys are free to comment, but it has to be with respect. There must be no offensive comment. And keep your video and microphone off. If you have any questions, raise your hand and ask, right? You do have access to unmute yourself. I have the chat box disabled. This way you guys can interact with the speaker. We are on social media as well. Follow us on LinkedIn, Facebook, Eventbrite, YouTube, Meetup, and Twitter. Also, don't forget to visit our community, our data community, which is Data Saturday and SQL Saturday. Today's presentation, as I already said, is related to your performance tuning checklist. We do have Monica Rathburn. Am I saying it right, Monica?
Rathbun, but yeah, we're good.
Perfect. It is an honor to have you here. Thank you so much for your presentation in advance. He is a Microsoft MVP for data platform and Microsoft certified solution expert. She will introduce herself and give you more information. We do have a tons of other presentations lined up. The next one will be Deborah Melken. She will talk about, beyond the basics select, and also the following one is Kevin Fiso, data virtualization with Polybase. I would highly suggest you guys to save your spot. And then if you guys have any presentation you want to submit, feel free to do that. And I'll be happy to have you to save a spot for you to share your experience with the community. And then feel free to email me your presentation at jean.joseph@bigdatadriven.org. And Monica, the floor is all yours. Feel free to share your screen, introduce yourself, and start with the presentation.
Let me get this set up here. Make sure, can you guys see my screen?
It's loading.
Let me know when you're able to see it.
It's showing loading.
Got it?
Yes.
Awesome. All right, everybody. Thank you so much for having me. I appreciate taking the time from your lunch to join us today. If you have seen my performance tuning big bang for your buck session, this is basically the same session, a little bit revamped. And I do that and have kind of reskinned this and added a few things because it happens to be my most important session. It is a session that I designed based on being a consultant. If I am coming into your environment, these are the things I really want to touch on and make sure you guys are doing inside the environment to make it as performance tuned as possible with a little bit of effort on your part. So this is where we're going to start. This is your performance tuning checklist, and we'll go through each one. The idea is for you to take this and literally use it as a checklist as you go through your system. You can find me at SQLespresso.com. I'm SQL Espresso on Twitter. You can find me everywhere using that. I am available for any questions you have as we go through this. And as when we're done, if you have any follow-up questions, you can find me again. LinkedIn, Twitter is the best place to hit me. You can email me I do work for Denny Cherry and Associates Consulting. I am the performance tuning guru when it comes to that. It is my bread and butter. I absolutely love doing everything with performance tuning and sharing all that information with everybody else so they can do it as well. I am a Microsoft MVP. I'm very, very busy in the community and try to get involved in as many things as possible. So definitely reach out if I can help you within the community itself or with performance tuning. I'll be happy to lend any assistance to you. The way I do my presentations is, and I'm glad he kind of turned off the chat and you guys can ask questions just by unmuting your mic. I really like to make sure in sessions like this that we share information that we have based on our environment compared to others, because as I go through this, there are some things that maybe you have tried in your environment that didn't quite work, and sharing all that knowledge with us really kind of helps each one of us make better performance decisions inside our environment. Something I might tell you works for some, it may not work for others. Or if you've had really great success with one of these, definitely share that, because that gives encouragements for other ones to go and make those changes as well. It's a two-way conversation. I do ask that since this is only an hour and 15 minutes, we don't hijack the session to particular issues you're having in your environment and looking for a solution. I can definitely take that offline with you and help you with those type of things. So let's get started and take a look. Everything we do starts out with best practices, and some of this stuff may be absolutely familiar to you. It may be very elementary to you, but it is the basis for how you have a perfectly tuned environment. And some of these things may have gone by the wayside within your thought process because it's so rudimentary. And I want you to go back and definitely take a look at each one of these best practice items and check it off in your environment to make sure it's actually being done in each and every single database, server, VM, setup, everything along the whole path that makes SQL Server run better, faster, and is optimized as much as possible. So let's start here. And again, if you guys have questions, let me know. This screen is really great to kind of print off as a start. I do have more slides besides these, but these are your big power hitters that we're going to talk about. Starting with number one, which is the easiest thing you can do, and it's outside of SQL Server, and is all about getting as much CPU performance in your environment as possible. And what happens is when you usually get a server set up, especially if it's not cloud related, or if you are on a VM, or maybe even bare metal, is to make sure that your power plan, yes, power plan, Windows power plans matter. Make sure you are set on high performance. And why does this matter? It is just a control panel power option on the server and on your host if you're on a VM. If you do not have this set to high performance, you are only using, look at that number, 70% of your CPU's capability. That means off the bat, if you are running on the default balanced plan, which is the norm for most servers outside of SQL Server, you've lost 30%. 30% of your CPU power just from this setting that is not SQL Server related. So please go back to each and every one of your servers. Make sure you're on high performance. Now, take a minute and Google this. You can find that there's different tools you can use. One called CPU-Z, to where you can actually look at the clock speeds and the amount of CPU that you're taking advantage of if you get any kickback about making this change. You can show before and after results and show that 30% degradation just by having this. So please take a moment and do that. Have the conversation with whoever is your VM admin. If you are on some kind of host, make sure those are also set to high performance, because their CPU regression of only having 70% will actually reflect on your box as well. So please go back and look at this item as number one. It gets caught all the time as we look at boxes, and we hear about it in forums and in other things of this still happening today. So it's a rudimentary thing. Take your time to go take a look. So the next thing, if you've ever inherited a box from someone who installed SQL Server and clicked every single box in the installation and installed all SQL Server options that were available, your box looks like this. And what happens is when you're running things like SSIS, SSAS, SSRS, maybe you have some of the other machine learning things put in, All of this takes away from your engine. And what matters most to us when we are performance tuning is that your engine is as optimized as possible, and it can use every resource available to it on that box. So please take a second and go to your services and make sure you just have the engine service and related items running. If at one time you chose to have SSIS installed on the box and then you stopped using it, make sure it's disabled and turned off. We run into many boxes where we have reporting services on there and SSIS that don't get used. And then it's using resources. We're going to talk a little bit about those resources that those consume and take away from the engine just by having them still enabled. So go back, double check what you have. We find a lot of times that there are things that were installed that are no longer used and should be taken apart. I'm sorry, should be disabled and not part of your box. Again, there's licensing issues on why you might have SSIS on the same box as your engine. I highly recommend that you do not, and you keep your engine isolated and have it only running on that box. I do understand there's reasons for that, but just make sure you're only running what is absolutely necessary and used, and have it properly configured to share that load on your engine box. So next, patching. Patching is a big one that everybody forgets that has to do with performance tuning. And I really need to make this clear. Everybody patches for security reasons, right? All the Windows patches get done. Maybe you do some patches when we used to have to go to just SPs, right? You waited for the service pack to happen and you ignored all CUs up to the service pack. Now we're releasing based on CUs. The actual upgrade should be happening faster. Why? It is all about performance for me. Yes, security is important, but performance. There are many bug fixes that happen in every single CU. And I know a lot of people look at the docs when CUs are released, but if you ever take a peek at it, you'll see many things change inside all the metadata layer. There's things in Tempdb that changes. There are actual code changes that happen, different options that change that make your performance better just by going to the next CU. And we're going to touch on a couple of those as we move along. But I want you to start thinking about these patches, about CUs and about performance, and make them happen quicker. Again, like when we had SQL Server 2016 released, Optimizer changed in a big way when you went to SP1. If you are not on SP1 minimally on SQL 2016, you have performance issues. I guarantee you have performance issues that you haven't even addressed, or could be the reason why you're having an issue and you just don't even know it exists, and it's going to be fixed in this CU patch that you put on. So I want everybody to just rethink how you're actually applying CUs and the importance of them. There's a lot of issues that are out there that can be improved that you just don't know about, and they're fixed by just adding the CU. Okay, so make sure you're doing that. On top of that, Microsoft support. We all know we don't want to call Microsoft support, and if we do, we pick up the phone, they're going to charge us hundreds of dollars an hour just to tell us that the version that we're on is no longer supported, and hang up the phone and you still have problems. That's when you call consultants like us that can still work on them. But you want to make sure you are actually in the Microsoft compliance in the version that you're on. So definitely take a look and start thinking about that. And if you need to use that as a reason to be doing your upgrades, it's definitely one that can save you money in the long run. Again, I'm always going to point out to things that are outside of SQL Server that affects your performance. And that also includes the drivers on your VM, your NIC cards, your domain controllers, your Windows patches, all of these which are outside of SQL Server and normally your purview and your control need to be updated. There are lots of different things that go on in a virtual environment that makes a difference. And also those that are in Azure, this is about the cloud, right? When you actually go to Azure and if you do SQL DB, you actually take on the version that occurred when you created that database, right? So if you go and peek, I bet you some of you are not on version 150. You might be a step lower from when you added that. So make sure you're looking in the cloud environment as well. Make sure you're on the up-to-date version, and you can just switch that compatibility level to the most recent to take advantage of some performance enhancements by going to the next one, including like intelligent query processing, things like that, that went into the 150 version. So definitely take a look at those, make sure you're on the latest to greatest, and it does apply when you go to Azure as well. So memory. Memory's a big one. And a lot of people get this first part perfect, right? Other people, the later items on this kind of confuses some people and can cause some major issues. One, everybody, if you actually go into your server properties and go to memory and you have this max memory set to this 2478647 number, then you are not treating your memory properly. What that does is allow SQL Server to use all available memory on that machine. And you really need to be able to control that to make sure that your OS and other items can share the memory within that box, and you can control how SQL Server is using it. So what I want you to do is there's a gentleman called Jonathan Cahias. He actually has a fantastic script that will allow you to get the exact number you need to put into that max memory. And what that does is allow SQL Server to take the amount of memory up to the limit that you put here and use it efficiently and leave the remaining stuff to the OS. Now, there's an old rule that says you take the max memory of a box, say it's 64 gigs, you leave 10% to the OS and the rest goes to this max memory setting. It's a start, right? But if you run some scripts that are out there, you can even Google max memory setting. It'll give you a script and it'll allow you, based on your box and certain algorithms and certain calculations that are actually existing, and give you the proper magical number to put in that box. Now, here's where the other items come into play. I've gone into boxes and found out that there are multiple instances, multiple installs of SQL Server on the same box. The people who have set up the box went and ran these scripts and actually put the magical number in for this max memory setting. Well, they did that for each instance. So if they had a box, the full box had 64 gigs, they went to the first instance, installed it, and had a max memory of 56 gigs. Somebody else installed another instance on the same box, put 56 gigs on it. What did they do? They just overextended their memory, and they ended up with 112 gigs of memory allocated between these two instances. So if you have multiple instances on a server, I need you to go through and make sure you're doing the math. Double check what your total allocation in that max memory is between the instances, the multiple instances that end up on the box. You could be starving your Windows or actually starving SQL Server because you've over allocated that memory. I've seen it so many times. If you have multiple instances, please take a look. Now, the multiple instances do not have to have the same amount of memory allocated between the two. One, if it's a less used instance, maybe it only has 12 gigs while the other has 42, or however you need to allocate it. Definitely take a look between multiple instances and make sure you're doing it correctly. Now, look at these extra services we talked about in the slide previous. If I have SSIS, this is a big one, SSRS or SSAS running on the box, that memory used for those services is not, I'll repeat, is not included and used by that max memory. That max memory setting is only for the engine. So if I've left 4 gigs to the OS and the rest set on this max memory, and I have SSIS, it is sharing that 4 gigs of the OS remaining memory for its application. So if you've got a large SSIS load and it actually needs more memory, it is starving your Windows memory to make their workload happen. So if you have any of these other services set up, you need to look and see how much you're consuming at your peak time to determine how much memory you need to be able to give outside of that max memory setting. Maybe your box needs 12 gigs allocated to the Windows box and all of these other services, and the rest can go to max memory for the engine. So if you have any of this, please take a look. I can guarantee you it is slowing down your SSIS packages because you may not have enough memory. You're probably getting low Windows memory alerts and you can't figure out why it's happening, and it's not having to relate with SQL Server itself. Take a look at these extra services. This is the big one that a lot of people don't realize is not shared. You can Google it. There's a couple other methods you can do to come up with how to allocate for each one of these services, but I guarantee you need to take a look if you're doing so. I have locked pages in memory here. I want everybody to research that. I'm not going to go deep dive into it. There is different reasons why you need to have this option turned on and where it can be detrimental, which is why I have the star. So I want you guys just to know for memory, we don't have a lot of time to go into it. Definitely take a look and research locked pages in memory before you actually just turn it on. The last one is a big one. when you're on a VM and you're on a VM host, you need to make sure you ask your admin to do a memory reservation for your memory allocation for that box. So when I ask for 56 gigs or 64 gigs on a particular box to be created for me, I need to go to my admin and say, please give me 64 gigs as a memory reservation for this particular VM. And what that allows you to do is to make sure that 64 is never touched when a host is trying to rebalance its resources if some other VM needs more. So there's a thing called a balloon driver. And what that does on a host, it's a really great thing. It will say this VM needs more right now, so let me borrow it from another one who is not using it at the moment. When it comes to SQL Server, I don't ever want that to happen. My SQL Server needs to be left alone. I don't want the balloon driver involved. I don't want it stealing any kind of memory from what's been allocated to me because I have no control over that. So how I can actually manage it is make sure that they set a memory reservation, and it's a little checkbox and a little setting inside the VM software or whatever software you're using to manage the memory on a host environment. So definitely take a look. And if you are actually using like a data center host environment that is out of your purview, I can guarantee you they are taking advantage of that balloon driver technology. You need to ask them as well to make sure your box has a memory reservation. Okay, so those are a few things you need to check on your side that I find all the time causes issues. When you're starting to see low PLE, page life expectancy, and stuff like that, these are one of the things you need to make sure you've got set up correctly in your environment. Okay, before I start into Tempdb, do we have any questions yet? Feel free to unmute yourself if you do. Okay, so I'm not hearing anything, but again, feel free. Tempdb, I have a session that can go for 4 hours just on Tempdb. I'm going to touch on tiny bit right here. These are the critical things that you need to know about and make sure you have in your environment. Some of this is so critical that it's being taken care of in future versions of SQL Server as we move along. 2016, 2019 has actually made this a little bit easier for everybody, but Tempdb is important. What I need you to make sure in your environment is that you're doing these items. One, and when you start to do the install, I believe it's 2016 this started, it might be 2019. You need to make sure you have multiple files. All your Tempdb is used by everything inside SQL Server. It's used by background operations, it's used by your temp tables, it's used by sorting, it's used by 1,000,001 little things, and it creates a contention issue. Contention is everybody vying for the same resources, it's vying for the same page, it's vying for the same empty space on a page and trying to decide where to write and use the data from. So it's important that you give it the most optimum scenario to share and balance the workload between multiple files. If you only have one Tempdb data file in your environment, you have contention that you can easily solve or improve by adding multiple files. Adding multiple files gives more special pages, PFS pages, GAM pages, SGAM pages, things like that, that help SQL Server reallocate and balance that workload and get rid of contention. So go into your environment, make sure that you have multiple files. I want to see, we're going to go with the old rule of thought. We're going to go with 1 file per CPU core up to 8 files. 8 is like a magic number inside SQL Server. It's where your cost benefit goes over. If you go past 8, sometimes they're switching between files, can cause more overhead, things like that. There are plenty of environments that require more than 8, but most environments will be happy with 8 files if you have 8 cores. So definitely have multiple files. And with that, notice what's in the red. This is the critical piece. If you go into your environment and you find that one of these files is bigger than the other, you have contention, you have a problem. Because it does a round robin when it does its workload, it actually will take all of your workload to the biggest, freest file that you have. So if number 1, if these are all set to 1,000 and my temp dev has grown out to 10,000, my entire workload is going to that first file, temp dev, and the rest of them are being ignored. Okay, so go into your environment today, tomorrow, look and see if they're misaligned. If they are misaligned and only one is bigger than all the rest, or if they're not all the same size, you have a problem and you need to resize all of these. Each one of them should be exactly the same size. These are data files I'm talking about, and your auto growth needs to be exactly the same. We want to make sure if one file grows, all of them grow. Now, as we've gone past install of 2016, the auto growth issue has gotten better because SQL Server will auto grow and make sure they're all working together as much as possible. If you are under 2016, there are two trace flags that you need to make sure you have enabled. That's 1118 and 1117. 1118 has to do with mixed instance. We're not going to go straight into that, but that has to do with changing the algorithm of how the mixed extents are created and used. 1117 allows that auto growth to trigger for all files at one time if there is a growth needs scenario. Keeping in mind, when you do 1117, that affects all file groups, not just Tempdb. So if you have another SQL database with multiple file groups and one of those file groups trigger, the rest are going to grow. So maintaining your space on your disk is important so you don't get into an out of disk space scenario. So keep those in mind as you do that. So from this, I need you to make sure you have multiple files. They're all the same size and they stay the same size. If you've got anything out of whack, you need to fix it and get them all back in sync. Now, I talked about CUs and making sure that you are on the latest and greatest. If you notice that number 4 box sitting here, heavy contention in metadata. In the background, metadata out of your control as your DBA, there was some issues inside 2016 and 2017, and each one of these fixed it in the background and got rid of a lot of contention and a lot of holdup inside Tempdb just by applying CU8 for 2016 and CU5 for 2017. So make sure you go back. This is something that was occurring. You had slowdown in your Tempdb and you didn't even know it probably and got magically fixed by applying these CUs. So make sure you're doing that. Also, very, very, very important. When using Tempdb and you use table variables, again, in 2019, they make this better for us. But if you are not in 2019 and use a table variable, it actually goes and creates a estimated row count of 1 and does all of its workload in all of the transactions inside your execution plan. Each one of those operators will estimate a number of row count of 1, which puts more weight on Tempdb because it needs to go to disk to do that overflow of row counts that wasn't granted in memory. I know I'm not explaining that in a ton I would do that in another session, but just know if you put in trace flag 2453, it allows your procedures to pre-compile what it needs on for your Tempdb estimated number. I mean, your row count estimated count, and will actually give you the actual count. What that does is instead of estimating a row count of 1, it will get the true count. Maybe it's 10,000 rows. So therefore, your memory grant will hold 10,000 rows and you won't have to use Tempdb for the overflow and go to disk to do the processing. It keeps you out of Tempdb and keeps you out of contention. So if you are using table variables, your magic trace flag is 2453. There is no downside for enabling this. It's so important that in future versions of SQL Server, it is now defaulted, and they have given us a table variable deferred compilation in 2019 to handle that for us. So table variables, those are the @ tables. 2453 is your friend. Please make sure it's enabled. All right, so this is another one that's so important that when we went to future versions of SQL Server, they're prompting us to make sure we set this. Yes, somebody has a question?
Yeah, I have a small question in the Tempdb.
Sure.
Yeah, is there any checkpoint available for the Tempdb?
Any checkpoint available?
Yeah, is it possible? Is there any checkpoint creates in the Tempdb?
Meaning, can you run a checkpoint?
Yeah, see, actually, for any transactions in a master MDF, okay, LDF, there is a one checkpoint. The same checkpoints is occurred in the Tempdb or not?
I believe so. I'm sorry, I'm having a hard time understanding your question.
See, what does checkpoint do in the Tempdb? Is there any checkpoints happens in the
The
Tempdb?
checkpoint in Tempdb works just like any other database.
Yeah, see, other database there are the checkpoints. The same like that. Is it apply for in a Tempdb also?
Yes.
Yeah, yeah. Is it possible to brief some information about the checkpoints in a TempDB?
So I have a blog out there regarding how to shrink TempDB, and it goes into checkpoints and what you should run. So if you go to SQLespresso.com, you will find TempDB, a blog out there. Actually, a 3-part series is out there that will actually dive into that for you.
Yeah, okay.
Okay.
I'll go ahead with it. Yeah, okay, thanks.
One more quick question about the TempDB. You
Sure.
said if the files are out of sync and the first file is a lot larger than the rest, and it's all being allocated to the first file, by
Correct.
just making them all the same size and all the same auto growth will automatically put them in sync, or what do you need to do to get them to be using all the files?
Yep. So one, I'm going to refer you to that same blog because I give you a bunch of scripts you can run to get them all back in sync. And I will put that on my screen before we go. I'll make another slide and put it in there. But so what happens is TempDB needs to run in a round robin fashion, right? You want it to allocate and spread the load between all of your files. If TempDB goes and says, hey, I need to find, if a transaction comes through and says, hey, I need to find space on a page to do my work, where can I go? It's going to go to the bucket that has the most space. So if my number one file is sitting at 10 gigs and everything else is sitting at 5, guess where it's going? To the 10 gigs. Another transaction comes through. It needs space. It's going to go to the 10 gigs. It's going to go to the 10 gigs. It's going to go to the 10 gigs. And you're going to get everybody trying to mesh into that first file. So what you really need to do is make sure SQL Server is doing the round robin effectively and the algorithm is going the way it's supposed to, the allocation, by doing all of the files in the exact same amount, 10 gig or 10 might be 10 gigs per file. You're giving it space equally on each one of those files, so it can round robin and place things throughout all of the files. Okay. Now, if you go through and you say, hey, I'm going to add another file, right? All of my files, I've got 4 here. I need to add 2 more. As soon as you add 2 more, I want you to plan a restart. Because what's going to happen is if I have 2 more files in here, those are going to be the most empty and free. So all of a sudden, everybody's going to my 2 files that I just added because it's empty, right? So when you plan a restart after adding files, it'll allow it to allocate through. Okay. You don't have to restart to add files. It's just an extra measure so you can make sure you're getting the allocation appropriately through the entire file structure that you have. Does that make sense?
Yes, thank you.
Okay. Yeah, so definitely check with this, and you should be checking this routinely because sometimes you'll get a transaction that is just going to blow out your TempDB. It's just going to happen, right? You're going to have an open transaction that's going to do that. So part of your DBA routine is to keep an eye on this, whether you set alerts so you know when an auto growth has happened, or you can check the file sizes and it can kick you an alert or something like that when one gets out of whack. But as soon as something gets out of whack and grows bigger than the other, you have a performance issue. Guaranteed. Okay. All right. I'm going to go ahead and move on. I might have my master TempDB session recorded somewhere. I'll see if I can find that and get you guys a link to it so you can watch it as well. So we're going to go to max DOP, which is max degree of parallelism, and the cost threshold. If you don't know what these are, I'm guaranteeing you in your system, this is currently set to a max DOP of 0 and a cost per threshold of 5. If those default values exist in your system, then these are items you definitely need to take a look. So what parallelism is if you don't know, it's when you're looking at an execution plan and you want it to go parallel, meaning you want multiple threads to be handling your workload in that piece of the transaction so it can go faster. You don't want a serial read, just one thread handling the workload. These two things work together to make the parallelism decision by the optimizer. So max DOP says, I'm going to allow, and I like to use the rule of thumb, I try to start with half max DOP of my cores, right? So if I have 8 logical processors, 8 cores, I'm going to set my max DOP to 4 and allow half of those threads. I can go up to 8. I can do 8 because I have 8 threads available. But I like to do half. Now there is some soft NUMA, some NUMA, and some other things that you take into account when it goes to this. But if you don't want to dive into it, at a minimum, what I want you to do is do half of your CPU cores is where I'm going to start. So I'm going to say my max DOP on an 8-core box is 4, which means I'm allowing that transaction to split out to 4 threads to maintain and get that workload to the next environment, or to the next node in my execution plan. Hopefully everybody's following me. Now, how cost works, cost says that I'm going to say it needs to cost the optimizer this amount in order for it to decide to go parallel. So if you have a ton of parallelism in your environment and it's too much, you can control this with the cost and say it must be, I like to start out with 35 to 50. It must have a cost of 35 to 50 for the operator to go parallel. Okay. Now, many of you guys have seen what we call CX packet weights. Those are a big indicator that you might have too much parallelism happening in your environment, and maybe you need to make some changes to these two options inside the environment. So what a CX packet weight is when I go out to those 4 threads, right? I'm in one node, it says go parallel, it hit the cost threshold. I get it spread out to 4 threads. Well, when it goes to the next node in my execution plan, it's got to bring those 4 together to process it. That is a CX packet weight. Bringing those 4 together is your weight. Okay, so if you have a ton of parallelism, if I was splitting out to 16, it's got to bring all those 16 together to move on, decide what the cost is, and then spread it out to parallelism again. So this is where you get into that weight scenario. So what I want you to do is look at your environment. Should actually set max DOP to half the cores. And again, in 2019, it prompts you for this in your installation. It's so important to where you can actually decide how many threads you're going to allow it to go. Now, if you're going to change this in an environment that's currently your prod environment, caution, when you do this, it will flush your procedure cache. Okay, so that means you're going to get a performance hit when you do this because it's going to have to warm back up your cache as you move forward, and that could take a while depending on your environment, so you can get that planned reuse. Okay, you can also do a max DOP inside a store procedure. So if I find that my store procedure when I'm tuning runs much faster with a max DOP of 1, meaning I'm allowing it 1 thread and I want it to go serial, I can do that in a query hint and actually control that there. If I need it to go out to my full 8 threads, my 8 cores, I can go ahead and change my max DOP inside that that query to go to 8. So you can make sure you can optimize things just 1 for 1 if you want to do something different than what your default value that you have set. Cost, again, a good start is 35 to 50. If you find that you're going parallel a ton, you can up that value to 70, 75, and go from there. Now, I have run into environments, and please don't ever do this, where someone set their costs for threshold for parallelism to 9,999, which meant that everything went serial. Okay, nothing was going parallel in their environment and everything was slow. So that's something to keep in mind. I do know if you're doing SharePoint, SharePoint only allows a max DOP of 1. That is the exception to the rule that I'm aware of, and that cannot be changed. Okay, so the key to this one is make sure your max DOP is not set to 0. Should be at least half of your cores, if not up to 8. Again, a magic number in SQL Server. Then also your cost for threshold parallelism, if it's set to 5, you need to reevaluate that. And a good starting point is between 35 and 50. Okay. Now, next. Okay, so this one's a piece of cake. This one is so easy. And it actually checks for it in later versions of SQL Server as you install this. This is outside of SQL Server, okay? This is just a group policy, a local security policy option within inside your environment. If you are using an AD group or you have a SQL Service account, I need you to make sure on that box it has the rights to perform volume maintenance tasks. That's all you have to do is add your SQL Server service account or whatever the group policy AD account is, and make sure it has perform volume maintenance tasks enabled for that account. Now, what does this do? I'll show you in the next slide the impact of this, but it avoids zeroing out operations on the disk before it writes to a file. So if you're doing a restore, you're adding files, you're increasing with an auto growth scenario, or you're creating a database, On the disk itself, it has to zero out and get that space allocated before it starts writing, which can really slow processing down. If you have instant file initialization, then it just goes off and running as soon as it gets the command to grow out or whatever it needs to do. I'll explain it here in just a second. So look at this. If I am creating a 5 GB database, just creating a 5 GB database, and I do not have this permission set in my local box for my service account for SQL Server, it will take me 1800 milliseconds to create a 5 gig file because it's got to zero things out and then start writing to that disk. If I have instant file initialization, it's a third of that time. It's only 600 milliseconds to actually create that file. Now imagine if this is a terabyte database. Or imagine if you have a database that's in an auto growth scenario and it needs to grow out 250 gigs or it needs to grow out 10 gigs. All of that growth in time slows down your SQL Server, creates a pause. It actually makes your stuff go slower as these auto growth or restore or creates processes happen. So you want to have it go as fast as possible. It is all about setting that local policy and giving permission to SQL Server, okay? And it's IFI. It's so important that when you go to 2019, there's actually a checkbox in the install if you run through the GUI, and it'll ask, grant instant file initialization, and it's just a checkbox. It's so important they put it in the install. When that happens, it's something you definitely need to look in your environment. There are queries you can run to find out if IFI is initialized or if IFI is turned on in your environment, if that permission has been granted. Or you can go, like I said, with that screenshot. I'll go back so you can see. And in the local security policy, if you see your user here, you've got it. If your user is not there, meaning your service account is not there, then you do not have it. Okay, simple as that. Must be done outside of SQL Server. Another option that you need to be made aware of. Okay. So this is a big one, and this is a magic button. It is so important that we'll see that it is defaulted in Azure SQL DB. If you have an environment in which you have blocking, right? You've got a production environment where you have transactions happening all the time and you've got people running select statements against it, or you have reports running against your production database. We all know it happens, or someone's running a big query and you've got blocking, right? What's happening is by design, readers block writers and writers block readers, right? We don't want anything writing to a page or to a row being changed or anything like that, insert updates, deletes happening while we're reading our data because it's changing, right? But so it creates a block. It happens. That's what it's supposed to do. But we don't necessarily have to deal with it. What there is there is actually an option that you can turn on. Again, it's defaulted in Azure SQL DB. This is what you should be having turned on. Allow snapshot isolation and read committed snapshot isolation. This is on a database level and should be turned on for each one of your databases. Now, there may be reasons why you might not want to turn it on. So always, no matter what I tell you, do your research. Don't just say Monica said to do it. However, in this case, this is your magic button. What it does is readers can no longer block writers and writers can no longer block readers. The way it does this is it starts to create a versioning table inside Tempdb of all of your rows and all of your changes. So when a reader comes through as a writer is trying to write, the reader reads the previous version of that record in a versioning scenario, right? So it's going to read the row versions inside Tempdb. Now you're going to say, is it going to get wrong data or dirty data or bad reads? No, it's not. SQL Server handles that. You will not have that issue. There is a thing called race conditions everybody worries about. That's kind of an older thought, in that it would create dirty reads or it wasn't going to be able to maintain this versioning table fast enough so your data wasn't correct. That is a misnomer now, and it's not what actually occurs. But here's the key. One, your Tempdb needs to be correctly done. You need to make sure you have proper spacing and you have it properly configured before you turn this on, because again, it holds your versioning tables inside Tempdb, right? So make sure you have that set. Second is, as soon as you turn this on, you're going to see most of your blocking when it comes to select statements, inserts, deletes, and updates that are blocking to each other. It's going to magically disappear. It is the magic button inside SQL Server. And again, it's so important that is the default isolation level in Azure SQL DB. Okay, so definitely if you have any blocking going on, I can tell you if I was monitoring your system live, looking at all of this and you turn this on, I can tell you where and when the exact time you turned it on because it just kind of floods and disappears. Okay, so definitely take a look. To turn these on, you do have to go, it has to get an exclusive lock, I believe. So you may have to do it on off hours. Don't just turn this on during the day, but definitely take a look. It is a winner for you when it comes to blocking. Okay, Kendra Little has a fantastic blog. Again, that's Kendra Little. If you look up RCSI, that's the read committed snapshot isolation, RCSI. If you go and look her up, she has a fantastic blog on this where you can really see how this works. So I highly recommend taking a look. So again, default isolation in SQL DB, that tells you a ton that maybe you should be taking a look at this. How are we doing on time? Okay, virtual log files. I'm going to go a little faster because there's, we're getting close on time. I want to make sure we get through everything. But I want you to understand this is, again, like a round robin scenario here. What happens in SQL Server when you actually have growth events inside your files, it creates these virtual log files. It's additional little buckets that happen inside your log file. And based on the growth, there is a mathematical increase in your log files or your virtual log files that you have within your log, okay? The more virtual log files you have, the more buckets a transaction has to go through to find where it can do work, okay? I'm trying to make it as easy as possible here. What you should have is, especially Tempdb, I see this all the time. If you look at my website, I do have a blog on virtual log files. And it will actually give you a script you can run to take a look and see how many log files you have in your environment. You should have I like to use 300, under 300 VLFs at any point in time in any log file that you have. If you go into something like Tempdb and see 75,000 VLFs, which I've seen inside your log file, that's way too many. That means it's got 75,000 buckets it has to go through to figure out where it needs to do its work, okay? Keeping it simple. So go in your environment, check your VLFs per database, see if you're under 300, great. If you're over 300, then you need to be resizing and right-sizing your log file. Usually you're going to have to shrink it down and then regrow it so you have a smaller amount of VLFs, virtual log files, in your environment, and double check your auto growth setting because that is key. If you're only growing by 64 megs, can you imagine how many chunks you have if you grew by 20 gigs, right? How many of those little chunks that it has to go through as it round robins throughout your transaction log to figure out where to do its work, okay? Simplifying everything, but you get the general idea. Take a look at that. Again, I have a blog on exactly how you need to handle those and how you find out how many virtual log files you have in each one of your databases, okay? Put it on your checklist, check it out. So this one is the most important slide coming up that I have in my entire performance tuning arsenal, okay? And everybody jokes me on this one because everybody knows I talk about it in almost every slide deck that I have because it's so critical, and it's all about ugly babies, okay? When it comes to SQL Server, it is all about making your entire environment run as fast as it can. And unfortunately, some of that environment is out of the realm of the database administrator, right? So we're going to have problems with storage. Storage is always a bottleneck. When it comes to network is always a bottleneck. Our VMs, the way they're configured, how those NIC cards are updated, how many controllers we have, all of this is set outside of SQL Server that can slow us down, create bottlenecks, and is in charge, it's in the realm of someone else. We all know when somebody comes to us and says, it's the database's fault, the database is slow, the database is bad, you're not good at your job, that kind of thing, or the SQL Server is misconfigured, we're talking about our babies, right? We want it to run as fast as possible. We're proud of our work. We know it's configured correctly. When someone comes at us and says, hey, you need to change this because it is my bottleneck, and I can show you all of these numbers that prove that you don't have something right, it's talking about their baby, and it's an ugly baby scenario. I've run into many environments where I've hit head on with storage admins and had a very adversarial relationship because it's very easy for me to point out in numbers, in pictures, that they are the problem with the environment. They, meaning their hardware, their configuration, things like that, not them personally. It's hard to separate out the personal versus the environment that you're in charge with. So how do I deal with it? I keep all of my admins drunk, fat, and happy. If I'm coming into an environment, maybe I buy donuts for the admin before I start asking them to look at their configuration, right? Maybe I take them out for pizza. Maybe I use my own money to give one of them a gift at Christmas and develop this relationship, because it is my job to point out the ugly baby in their environment to make SQL Server run faster. So the key to this is just to make sure, one, that you keep a good relationship with your storage and network admins, because you're going to be asking a lot of them to make your stuff go faster. Two, it's your job to find the issues that make your stuff go slow. All of that sometimes is outside of SQL Server, and you're going to have to get those fixed. I don't care if I hurt somebody's feelings. I don't care what the issue is. I just need to make sure SQL Server runs as fast as possible. That's our jobs, right? That's what we get paid for. That's what we need to do. And I need to find a way to make those changes happen as quickly and easily and as efficient as possible. And if that means bribes, keeping my admins drunk, fat, and happy, that's what I'm going to do, because I need to make sure these changes are made. Okay, so just keep this in mind when you're working in any environment that has bottlenecks that are outside SQL Server. This is critical. It is your #1 performance tool, right? Making sure that all environments play well together and you can get those changes made. Okay, all right, I'm off my soapbox on that. So let's talk about one of those ugly babies, and that is going to be our VM host, or whoever sets up our virtual environment. We want to make sure that those are not over allocated, that we have our locked pages in memory. I'm sorry, we have our memory reservation taken care of. We don't have an overloaded VM where they have Exchange running on the same host as SQL Server, or they have some monster VM on the same box that we are on. We want to make sure SQL Server gets isolated by itself. It's not moved in between hosts all the time. It's not having its balloon driver steal my resources when I don't know. All of this has to do with your admins, right? If we have one VM taking all the resources from ours, we have a problem, right? We don't have purview necessarily. You can ask to look inside the VM software so we can see what's allocated to the same box that we're on. Many of us don't have that. If you've got a great admin, you can ask for it and kind of take a look, so you can look at measurements to figure out what's going on that host. There are some over and under CPU allocation issues that can cause SQL Server problems. SOS scheduler yields inside SQL Server, that wait type, will tell us that there could be a problem with scheduling threads, right? Our CPU issue could be throttling based on the amount of threads that are available on our VM host, right? How do we know that that's an issue? Well, SOS scheduler yield kind of gives us a hint, but we also need this CPU ready time metric that is actually on the host to correlate and make sure that's our issue. How do we get purview to that? A good relationship with our admins so we can talk to them and figure out what's going on. So these are things you have to be looking at that are outside that can deal with when you're in a virtual environment. Another thing when it comes to storage, right? Storage. There's a thing called thin provisioning, which is this hidden thing that our storage admins don't tell about. So let me say that I need to create a Tempdb. I need 500 gigs for this brand new Tempdb, right? I'm giving 100 gigs to 4 of my data files and another 100 gigs to my to my log file, okay? So I go to my admin and say, hey, I need 500 gigs on a T drive. Can you give that to me? And the admin looks at me and says, Monica, you don't need 500 gigs. You're crazy. It's a brand new database. You're never going to use that. And I'm going to say, yes, I do, because I'm planning ahead. I know I'm going to end up growing. This is what I actually need. He says, okay, I'm going to give it to you. So I look at my T drive. My T drive has 500 gigs presented to me, right? I can see it. It's there. But what really happened is they were sneaky. They thin provisioned that drive, which really means he gave me 100 gigs. He shows me 500, but he thin provisioned 100 gigs. When I hit that 100 gigs, it will give me another 50 gigs. When I hit that 150, it will give me another 50 gigs, all in the background. I don't know this is happening, and I don't know when it's going to happen. Every single time it gives me that next chunk and allocates that to me, I have a performance hit inside SQL Server. And I definitely don't want that happening during tax time or during some big event. All of a sudden, I've got all this bottleneck on my storage because it's allocating this space that has been thin provisioned. So what I need you to do is when you're asking for space on site for your SQL Server and in your drives, tell them you want it thick provisioned. That means they have to give me the 500 gigs up front. It's allocated to me. Nobody else gets it. It's mine. It's thick provisioned. It prevents me from having these growth events, and it gives me the amount of space that I want right away. Now, if they say no, especially when it comes to Tempdb, I want you to go ahead and grow out all your files. Go ahead and make every single one of them 100 gigs and take the 500 gigs. Then you just go ahead and don't have it auto grow after that. Take the space right away, because those hits of those growth increments that are happening when it's thin provision is significant to cause you some major problems and some delays as that space gets allocated. Okay. So this next one is a big one, and it all has to do with backups and restores. Okay. Compression. Page compression and row compression allows you to get more data on a page, meaning it cinches up that data and you can get more. I know a page only holds a certain amount of data, but if I have it compressed, I can get more stuff onto that page that would have flooded to a different page. Hopefully you're following that. So the more data you can get onto a page, the more data you have in memory, right? So the best thing you want to do for performance is keep as much in memory as possible. If I do a query and I can get it out of memory and I'm not going to disk, then I have things running faster. So page compression, row compression is definitely your friend when it comes to things like indexes and getting that stuff into memory faster, quicker, and you're able to reuse, right? And compression saves space on a disk, of course, right? So all of our storage admins absolutely love compression, right? Backup compression is your friend. If you can get your backups compressed, that's great. The overhead for compression is you lose CPU speed, but it's worth it when it comes to keeping more stuff in memory and saving space on disk. Now, here is the caveat, okay? I'm going to go ahead and say I want to have compression, and my storage admin comes and says, hey, I need you not to use compression on SQL Server. I don't know how many of you guys have had this come to you, but they say you can't have backup compression. You can't use compression in SQL Server. Can you stop doing that? And you try to say, okay, why? Why can't I do compression? Here's why. It's because they are doing compression on the SAN or whatever storage that they have. They have turned on compression because their sales guy and their understanding is compression on the SAN means they have more space they can use, right? It's a money saver. But here's what happens with SQL Server. When they do compression on the SAN, they also do a thing sometimes called deduplication, which means part of their compression is actually deduplicating data and creating these pointers, right? So the pointer will have the original data and it'll dedupe it, and everything has to go to this pointer, and it creates this spider web of pointers on the disk itself, and that's all it has to hold. Now, what happens when I'm backing up to a deduped SAN? Okay, I want to think about this. I'm going to put my backup on this SAN, right? It's going to deduplicate the data, and all of a sudden I've got all these pointers inside the storage. When I need to restore that data, my backup is fine. It runs just as fast. I'm good. But when I need to restore that data, guess what happens? I have to take all of those pointers and bring it all back together before I can restore. So we have seen 6 times the difference in timing for a restore that is deduped versus non-deduped and regularly compressed, natively compressed within SQL Server. So if I have a 2 terabyte database and I restore it natively, I do a regular backup, I put it off in the cloud, not on a SAN that's being deduped or wherever I put it, this 2 terabyte database might take me 6 hours to restore. Okay, maybe we have slow storage, or maybe it only takes 2 hours to restore, right? I've got a catastrophe situation. I've got to actually restore my database. It takes me 2 hours. I've got a VP standing over my shoulder saying, is it done yet? Is it done yet? Is it done yet? If I had it on a deduped storage, compressed storage array that's doing this, it can take 6 times. So it will take me 12 hours. 12 hours to restore that same file. You can test this very easily by doing your backups off site and on the cloud or wherever you want to put it. or even locally on your own drive or your whatever drive that you have that's not compressed, and then do one on a deduped one and show your supervisors how long it takes for you to be able to repair something or replace something and restore that database. If they sign off of it in writing and say that's okay, fine, then your storage admin wins and you're allowed to do it on a deduped compressed storage array, okay? So it's important. Make sure you look at those times. You can actually do the timing and put it in a graph or whatever you want to do, but make sure you guys test that if you ever have a storage admin come to you and say you cannot use compression on your backups. That's the key, okay? And many of those actually happen when you're using a backup product, right? There's several products out there that allow you to go to their appliance and their native backups and whatever they do in there. The key is that deduplication. It's going to take longer when you do a restore. So definitely take a look. And you can do the research on it. There's plenty of things out there. Things get better as arrays get faster, things like that. But there is a difference. Make sure you have that conversation, okay? Next thing, and we're getting close to the end, I'm hoping. We got a few more slides. I know I'm over. I will try my best. Query optimization, statistics. Statistics are key. It's the magic sauce that tells the optimizer how many rows to expect. Therefore, it can allocate the right amount of resources such as memory to make things run faster. It's important that your statistics are maintained. There's lots of queries you can run. Aaron Stiletto is a fantastic resource when it comes to statistics. Making sure you're looking at when the last time your statistics were updated. Do you have auto statistics set on? When you have that on, there is also another option on the database that says asynchronous versus synchronous auto statistics updates. All of these should be set to asynchronous. When you have a statistics update happen where the amount of row has changed, the amount of rows has changed in your table enough to kick off a statistics update, it pauses your system, allows that statistic to update so the query can actually use the newest statistic. If you put it on asynchronous, you do not get that pause and your query can actually go through. And when the environment is able to update that statistic, it will, and then you'll get the new one. So you can eliminate a little bit of lag that you can have if you have it synchronous versus asynchronous. Keeping the statistics up to date, if you have to set that in a job that actually runs nightly, hourly, depending on what your usage is, weekly, make sure you're actually maintaining those. 2371, a very critical trace flag you should have. If you have a table that has multi-million rows in it, say 15 million rows, 100 million rows in it, or whatever, statistics change based on the row change, right? The amount of records changed plus a percent. That algorithm decides when it's going to kick and give you a new statistic. If you have millions and billions of rows, that number is huge before you actually get a statistic update. If you put in 2371, it changes that algorithm based on the size of your table, and you can get quicker statistics updates and help you. So it's so important. Again, it's a defaulted thing in 2016 forward. So make sure you do that. Also, when you're looking at execution plans and you ever get that get a warning that says missing statistics, guess what? Maybe you should create a statistic. You can right click on a table, create statistic, and actually put statistics in there, multi-column statistics, or whatever the statistic it says is missing. You can make your own to give the optimizer a better chance of creating a better plan for you, okay? Statistics are key. Make sure you know about them and do them. I've got 2 more slides, and so hopefully we'll get you out on time. Indexes. This is so critical. Everybody knows indexes are important. It's what makes things go faster. If you're properly indexed, then you can make things fly. Well, it's important when you're creating indexes and when you're doing performance tuning that you also care for your indexes. They are not a set it and forget it. Everybody knows they need to do index maintenance. You do your reorgs and your reorgs and your rebuilds. Fantastic, right? You have that on a regular maintenance regiment that you take care of, but there's more to it. One, are you removing indexes that are no longer needed, right? You need to take a look and see if you're wasting IO, right? Are you wasting writes? Every single time you inset a record, delete a record, or update a record, your index is being changed. It has to look at them and maintain it. If you have a table that has a ton of indexes, that's a huge IO impact on your environment. So be taking a look. There's queries you can run out there to look at DMVs to find out if you're using indexes. Do those. Take a look and see if you're getting seeks versus scans, or you're getting a ton of writes to your indexes, but you're not really reading off of those. When you're looking at these DMVs and you're taking a look at these regularly, maybe that's quarterly for you, I need you to remember that these statistics that tell us all of this information inside these DMVs, they get wiped out on every restart or reboot of your server, okay? If you're in Azure, if you're in the cloud or not, if you're on a serverless and you pause the your database on serverless and it restarts, that means after it's come out of the pause, you've lost all that information and it resets. So you need to keep these things in mind. Know when your last reboot or restart happened so you know how good these values are that you're evaluating on whether you're using an index or not. Definitely script them out and disable them before you delete them in case someone needs it. Keeping in mind that some indexes are used for really large reports that are only run quarterly or only run at the end of the month. And you want to make sure you don't actually delete an index that you might need to make these important reports running faster. So this is part of the maintenance stuff that you should be doing. Finding missing indexes in your environment, right? There's lots of scripts you can run to find missing indexes. The thing about missing indexes is don't just add it. If you look at an execution plan and it says you have a missing index, don't just right click and script it out and add an index. Please don't do that. It creates a lot of duplicate indexes. Some of the indexes that are actually created and given as part of an execution plan missing index is not in the order that it truly needs, right? It's putting it in table order. You need to make sure you are evaluating all missing indexes that it's asking for. There are scripts that you can run against DMVs that will give you all the missing indexes in your environment. You can evaluate those, but before you add them, look and see if you have an index that's already just like it in your environment. Maybe it's just missing an included column, okay? Maybe it's just slightly different in the included columns that it has, and you can just add one. You want to make sure you're avoiding duplicates, not only because it wastes read and write IO to those indexes, but it also creates duplicates in storage, right? All of this has cost. You want to make sure you actually are creating indexes that you need, and you don't necessarily have to have it if you have an index that's similar that you can modify, okay? Start looking at missing indexes a little bit different. Don't just off the cuff add, okay, because something says that. And that includes in Azure. In Azure, you can actually get index recommendations as part of its automatic tuning stuff that happens. You need to be double checking those before you just add those indexes, okay? Making sure that you can't, you don't actually create a duplicate. Also in your quarterly reviews, go through and script out all of your indexes. There's plenty of queries in there that you can do that. Put them in Excel, sort them, and see if you have duplicate index scenarios where you can actually consolidate and combine your indexes. All of this is part of index maintenance, right? It's not just your reorgs and rebuilds. Covering indexes, we're going to talk about that in just a second. Those are what I mean when you're taking your indexes that are very similar and you can actually consolidate the indexes, especially when it comes to the included columns. Okay, this is my last slide. So we almost made it. It's 1:06. Sorry, it's so long, but it's a lot of good information that I really want to make sure you guys have. Execution plans. Execution plans, if you don't know what they are, when the optimizer creates a plan on how it's going to do each one of the queries that come through the system. It actually makes decisions based on many things, cost for each node that it might go through, each operator that it goes through, lots of things. And some of us don't necessarily have to understand that in order to tune. If you're novice at query tuning, this is something you can do that can actually get you some really great performance increase. Just these 4 items I have right here, 1, 2, 3, 4. Yeah, 4 items I have right here, you should pay attention to. By fixing these, you can make a huge difference in your environment. 1, missing indexes, right? We just talked about those. Are you getting any missing indexes that you can add? Again, evaluating what you already have. Do a more granular review. Use the DMVs that are out there. I do have some queries on my website as well that you can go and grab that will allow you to compare and see your seeks versus scans. Are you scanning? Why are you scanning? Seek means you're going directly to that index. You're finding it just like a phone book, right? You get index at the back and you're going and you're grabbing exactly what you need. Scan means it has to read the whole page to get to what it needs to do. 1, are you scanning because the order of the index is not right? It is not matching the queries that are coming to it. Maybe you can just change your query and it changes the order of the query and it changes that it gets a seek rather than a scan. Maybe your index needs to be changed in the order of what the fields are. There's things like that you can take a look at. Sorts are a big one. Sorts are one of the most expensive things inside of an execution plan. You need to be asking yourself, why are you sorting? If you have a stored procedure that sorts 5 times, because as you were developing it, you put order by under each query statement that you had as you were writing it, but you really only need to sort it at the very end, you need to take out all of those other sorts. It's a huge cost. It's a huge performance hit every time you do a sort. Why do you need to sort? Do you have to sort? Can you sort if it's used in a report? Can you sort in the report and not sort in your stored procedure? Many times inside of a report that's using this data, it gives you several different options on how to sort your report. If that's the case, don't sort inside SQL Server. Don't incur that cost when it's being done again. And when you're doing your development, developers, take out any order bys that you have that you definitely don't need in your final result set, okay? Key lookups. Key lookups are huge. Key lookups can be a death by 1,000 cuts when it comes to CPU, okay? What a key lookup does, and hopefully you guys can see my mouse here, is if I have a query that goes and says, I need field A, B, and C where it's equal to C, okay? This is the example. So it's going to use my where clause, where it's equal to C, and it's going to do an index seek here on order lines. But I also need to return field A and B, because remember I said select A, B, and C where C. So here is my index where it looked up C and it was able to find my data right away, but then it has to go to my primary key to grab field A and B that's associated with it. So instead of just going a seek and grabbing everything that I need and returning my results set, I have to do a secondary lookup, a key lookup on my primary key to get the additional fields I need. Then it brings it back to a nested loop, which is costly, out to a select. If I had an index that was an index on C, include fields A and B, then I skip all of this. It will go index seek to a select and I'm done. So imagine if you're looking up millions of records and you have 6 key lookups in that one store procedure. That would be 6 million extra round robins that I would have to do to my primary key to get that data. If I'm able to do just an index seek with included columns as part of my results set, which would be what I'm using in my order by or what I'm using in my select statements, then I can go straight from an index seek to select and I'm done. So you get a huge performance hit, you say a performance gain by saving on IO and all of those extra reads you have to do with the key lookup. And there's queries you can run to find all the key lookups in your system. Start attacking those. Very, very easy to do. It's all about included columns inside your indexes. And you can clean up a system so quickly just by getting rid of those key lookups, right? There's also a thing called an RID lookup, a RID lookup. That is the same thing as a key lookup, except for there's no clustered index on that table. That's the only difference. So getting rid of the key lookups and the RID lookups is your magic button when it comes to quick tuning in your system, okay? Spills to Tempdb, we're running close to being out of time. This just means that it did not get a big enough memory grant for the amount of rows it actually had versus your estimated rows that it got through. So it had to spill to disk, which means it spilled to Tempdb to do its workload. Tempdb, again, is shared by everybody. You can get in contention scenarios. So you want to avoid those spills to Tempdb. And it's all about the memory grant, it not being big enough for it to handle the workload. Estimated versus actual need to be as close as possible in counts, which means statistics. Statistics manage that. Making sure your statistics are up to date will prevent that from happening. Also, using that trace flag 2453 is what I'm thinking of the top of my head for your table variables, will actually prevent you from having to do that row count of 1 when your actual count is in the thousands and you get a bad memory grant and you spill to Tempdb. So it all comes together when it comes to this checklist. Making sure you go through everything and double check all of these. Some of these are really rudimentary. Some of them are outside SQL Server, and some of these things are just what we have to maintain in our environment quarterly, monthly, weekly, just to keep it in the most optimized state so you can actually maintain the performance as you move along all of these best practices. So I know I'm over at time. I apologize. I hate to impede on your guys' lunch hour or whatever it is on your work time, but thank you so much for sticking through. If you have any questions, let me know. I'm going to turn it back to you, John. and we can take any questions, or you guys can follow up with me via Twitter or wherever else that we have that we can link it, LinkedIn or my blog site.
To be honest with you, that was an outstanding presentation. Thank you so much, Monica, for putting all of this together. If you guys have any questions, feel free to unmute yourself and ask.
All right, I do have this slide deck available on my website. Again, it's there at SQLespresso.com. There is the VLF blog you should look up. There is one on key lookups, and there is the slide deck for Tempdb is also there.
Did you say you were going
If you
to
guys,
put that connection someplace? Or
I'm sorry, say that again?
Did you say you were going to put those links up someplace or working with vendors?
I can't put it in the chat. Let me see if I can.
can you email them to me? And I will share it across.
Sure. So I will, are you going to put it on Meetup? We can give you a few links on Meetup.
Yeah, you can share them with me when I'm
Okay.
sharing the recorded video, and I will add them as well.
Okay. Yep. I'll reply to you an email with all the links that I've referred to.
Thank you so much. Are there any more questions? Just give them 30 seconds, and thank you so much, Monica. I learned so much from your sessions, and I hope to have you next year.
Thank you. Absolutely.
Thanks.
Yeah, that was
Okay.
very informative. Thank you very much, Monica.
You're welcome.
Thank you very much, Monica, for providing the good, outstanding performance on this part. So thanks for that.
Absolutely. Thank you guys for attending. I appreciate it.
Yeah, thanks. So is it possible to share this recording sessions to my mail address?
Will do.
Yeah, thanks. Thanks for sharing the information. So thanks. Thanks. Bye, Mon.
Thank you very much for the good information, Monica.
You're welcome.
Seems like there are no more questions. Thank you, everyone, for attending. One more time, Monica, thanks again. Thank you all. Bye. See you next
All right.
week.
Bye, everyone. Have a great week.
Have a good week. Thanks. Bye.